Hi students, again complex numbers. The application of complex number, real life context, engineers, doctors, scientists, vehicle designers and others who use electromagnetic signals need to use complex numbers for strong signal to reach its destination. So it is plays a very vital role in these places. That is the best application of our complex numbers. Now we come to the powers of imaginary unit I. I power 0 equal to 1. This is I power 0 equal to 1 and I power 1 equal to I. I power minus 1 is nothing but 1 by I, that is equal to minus I. So wherever I power minus 1 you can substitute by minus I, and I power minus 2 is nothing but 1 by I square. So 1 by minus 1, that is also minus 1. Okay. So this is small revision of your first exercise. Now the new concept, it is called a rectangular form of complex number. A complex number is of the form x plus iy, where x and y are real numbers, is called the rectangular form of complex number. So whenever you have x plus iy, it represents rectangular form of complex number. Okay. Now the next one is plays a very important role, arc and plane. If we consider x-axis as real axis and y-axis as imaginary axis to represent a complex number, then the xy plane is called a complex plane or arc plane. So what is the difference between normal x-axis on y-axis and arc plane? Normal y-axis you have numbers, but in arc plane you have 2i, 3i, 4i. That's the difference between normal xy plane and organ plane. Okay. So now we are going to continue exercise 2.2. The second question, given the complex numbers z equal to 2 plus 3i represent the complex numbers in the organ diagram. You have three questions, that is z, I, z plus I, z, and number 2 z minus I, z and z minus I, z. You have to find the value of these three numbers, then you have to plot the numbers in the organ diagram. So z is given 2 plus 3i, no doubt, and your I, z is nothing but I into 2 plus 3i is equal to 2i plus 3i square. Your I square value minus 1, so it becomes 2i minus 3, that is in standard form minus 3 plus 2i. So this is not in your standard form. Your standard form always number, that is real part first and imaginary second. And your z plus I, z value 2 plus 3i, I, z value minus 3 plus 2i. I am adding these two. Your answer will be minus 1 plus 5i. Now how to represent in the diagram? Y-axis is imaginary, x-axis is real. So the first number 2 plus 3i, here I have 2 and this is 3, so your z is here 2 plus 3i. Like that your I, z, here is your I, z, minus 3, this is considered 2i, so minus 3 plus 2i. Like that your z plus I, z is minus 1 plus 5i, minus 1 plus 5i. As usual, your graph, how you will mark the numbers like minus 1 in the left side and plus 1 in the right side of your x-axis. Like that in y-axis, top you have plus value, bottom you have minus value. That's it. Now the second question, your z again the same number is 2 plus 3i minus I, z, minus I into 2 plus 3i, that becomes minus 2i minus 3i square. So again I square minus 1 into minus 3 is plus 3. So your standard form 3 minus 2i, and z minus I, z, it becomes 2 plus 3i plus 3 minus 2i, that becomes 5 plus I. As usual, your imaginary axis, real axis, and your first number z is 2 plus 3i, and the second number 3 minus 2i, 3 minus 2i, and the third one 5 plus I, 5 plus I. That's it. So this is your diagram. You don't confuse with your normal diagram, that is graph. Number third question, find the values of the real numbers x and y if the complex numbers, the two numbers are equal. So you just equate the two numbers. How to equate the two numbers? When we can say the two numbers are equal means their corresponding real values are equal and the imaginary values are equal. So we have to separate real and imaginary, both left side and right side. So what I am doing is just multiply the inside terms. It becomes 3x minus ix, like that. Minus 2 into y minus 2y, minus into minus I plus I into y is plus iy, and 2y plus 5. In right side you have 2x minus 1 into y minus y plus 2iy plus 3 plus 2y. I differentiated the imaginary parts, the red line, and the real parts, no line. That is 3x minus 2y plus 5 is your left side real part, and right side is 2x minus y plus 3, equating real and imaginary parts. Your real is 3x minus 2y plus 5 equal to 2x minus y plus 3. At the same time, your imaginary minus x plus y plus 2 equal to 2y plus 2. You have to minimize the equation. From the first one, all the terms you take one side. It is 3x minus 2y plus 5 minus 2x plus y minus 3 equals to 0. That becomes x minus y plus 2 equal to 0. And your second equation, minus x plus y plus 2 minus 2y minus 2 equal to 0. From that we are taking all one term one side. Minus x minus y equal to 0, that is x plus y equal to 0. That will become x equal to minus y. I can replace this equation, that is minus y equal to minus 2, minus 2y equal to minus 2, that becomes y equal to 1. Therefore your x and y values are minus 1 comma 1. Okay, your 2.2 over 2.3 we will see the next video. Thank you.